Hello everyone. In this lesson, we will review the process of finding the inverse Laplace transform of a function. Given function fs equal to s plus 9 divided by s squared plus 6s plus 26, please note that s squared plus 6s plus 26 is a quadratic denominator. As a reminder to everyone, I would like to draw your attention to the concept of partial fraction. So what is partial fraction method? Partial fraction method applies when the quadratic denominator has obvious factors. So how do we know s squared plus 6s plus 26 has obvious factors? One way to find out is to evaluate b squared minus 4ac. As you know, b squared minus 4ac is the discriminant of a quadratic equation. We will borrow this concept to apply to our quadratic denominator to figure out whether or not we can factor s squared plus 6s plus 26. So let's review that. If b squared minus 4ac greater than 0, then the quadratic is factorable. If b squared minus 4ac is less than 0, then I have to use completing the square method. So let's apply that to our 6 squared plus 6s plus 26. So b squared minus 4ac, with this quadratics, I should have a equals 1, b equals 6, c equals 26. So I will have 6 squared, subtract 4 times 1 times 26. Obviously, I will have a negative value here. So I have 36 minus 104, which is equal to negative 68, so it's less than 0. So I have to use completing the square method. So now we have to review completing the square method. So s squared plus 6s plus 26. Completing the square method, we need to concentrate on the middle term of this quadratics. We need to pick the coefficient of the middle term. We divide it by 2. Then we get the result. We take the result, square that. Then we add that with this expression, and at the same time, we subtract that result with the expression. Alright, so let's start on the next page. So positive 6s, I will pick the coefficient 6, I divide it by 2, I should get positive 3, and then I will square this positive 3, I got 9. So I need to add 9 to this expression. At the same time, I must subtract 9 plus 26. So basically, what you need to achieve is that you add 9, subtract 9, because you don't want to change the values of these denominators. If you add 9, then you must subtract 9, so that you can get back to s squared plus 6s plus 26. But we need adding 9 and subtracting 9 in this case. So in this case, what you do is you group the first 3 terms. And s squared plus 6s plus 9 is the expansion of s plus 3 all of it squared. So let's check that. S plus 3 times s plus 3 equals to s squared plus 3s plus 3s plus 9. Collect the middle term, I have s squared plus 6s plus 9. Okay, so s squared plus 6s plus 9 is the expansion of s plus 3 all of it squared. So the next step is evaluate negative 9 and positive 26. So negative 9 add 26, I should have positive 17. I need to convert this into a square. So convert that term into a square. I can write it as square root of 17 square. Square root of 17 square will give me 17. So it's very important to write both terms as a square, as completing the square. So it's very important at this point to note the statement. And before we go any further, I would like to draw your attention to the Laplace transform table. So on this Laplace transform table, we are going to look at this column. And we are going to go down the list to look at the statement where we have the denominators as the sum of the two squares. But one of that term has to be a binomial. So in this case, I found transform number 19 and transform number 20. So take a look at this. Okay. So in this denominators, what I have is I have s plus a, which is a binomial square. And on this numerators, I have b, and b is present as a denominator. And transform number 20, what I have is I have s plus a all of its square. And s plus a, here's the a, and a is present in the denominator as well. So let's get back to our solution. And we should write that down. So we are going to use transform number 19, and we use transform number 20. Okay, so at this point, I need to break this fraction into 2. So I will have s plus 9 divided by s squared plus 6s plus 26 equal to the sum of two fractions. Adding two fractions, you need to have the same denominators. So I write s plus 3 all of its square plus square root of 17 square, s plus 3 square plus square root of 17 square. Then I need to find the two numerators here. Okay, since we are using transform number 20 for this, I need to have a equal to 3. Okay, that means my numerator, I need to have s plus 3. Okay, so I'm going to use transform number 19 for this fraction. b is equal to square root of 17. However, I cannot write square root 17 just yet. I have to write 6. The reason for that is, if you take 3 plus 6, you have 9. So 3 plus 6 equal to 9, which must be equal to your original numerators, which is s plus 9. Okay, so let's move on to the next page. And I would like to rewrite what we just have. Okay, so s plus 9 divided by s squared plus 6s plus 26 equal to s plus 3 divided by s plus 3 all of its square plus square root of 17 square, add 6 divided by s plus 3 all of its square plus square root 17 square. And if we apply the transform number 20 for this, I should have a equal to 3, b equal to square root of 17. So I'm okay with that. Then this transform, I should use e to the negative at times cos of b times t as the argument. So for this particular fraction, if I use transform number 19, b is equal to square root of 17, but I have 6. So I need to do some calculation here. Okay, so let's write it down. What I will do is I will multiply this by square root of 17. At the same time, I have to divide it by square root of 17. So let's write the denominator back into this fraction. Okay, you can pull the 6 and write it outside the bracket. So this one now, exact match of my transform number 19. So transform number 19 tells me that I need to write e to the negative at times sine of b times t as the argument. So now at this point, we are ready to transform this into another function in terms of time. So I will write Laplace inverse of fs will be equal to e to the exponent negative 3t multiplied by cos of square root 17 times t as the argument. And this one I should have 6 over square root of 17 multiplied by e to the exponent negative 3t multiplied by sine of square root of 17 t as the argument. At this point, we should simplify our answer. Okay, so this one is ft. So I will factor out e to the exponent negative 3t. So inside the bracket, I'm left with cosine of square root of 17t as the argument. At the same time, I would like to rationalize the denominators. So rationalize the denominator means that I multiply square root of 17 to the denominators and also to the numerators. So when I multiply square root of 17 to the denominator, I should have 17 left. That means I don't have any more radicals as the denominators. So sine of square root of 17 t as the argument. So let's double check. E to the negative 3t, e to the exponent of negative 3t, cos of square root of 17t, and this term is correct. This term is correct. Then we are done. Let's move on to the next question. The next question I have in this lesson is also a quadratic denominators. So in this case, I have s squared plus 4s subtract 32. Okay, so again, we need to remind ourselves that do we have to use partial fraction method here? Okay, yes we do, because this s squared plus 4s subtract 32 is a quadratic and it has obvious factors. How do we find that out? Okay, so let's go back to our previous example and we examine this. B squared minus 4ac is greater than 0, then this quadratic is factorable. So at this point, many of us realize that s squared plus 4s minus 32 will be equal to s plus 8 multiplied by s minus 4. Okay, so let's double check that. B squared minus 4ac. So in this quadratic, I should have a equals 1, b equals 4, c equals negative 32. So I have 4 squared subtract 4 times 1 times negative 32. I should have 16 plus 108. So let us check that. Actually, 16 plus 128. Okay, so 128. Obviously, this is greater than 0. It is equal to 144. So it's greater than 0 is also a perfect square. So how do we know that s squared plus 4s subtract 32 equal to s plus 8 multiplied by s minus 4? So in this case, let's review how to factor this trinomial. Factoring this trinomial, you have to find two numbers, and the product of that two number will give you negative 32. So in this case, 8 times negative 4 will give you negative 32. The same two numbers, 8 plus negative 4 will give you positive 4, which should be equal to your middle coefficients here. Right. At this point, what I will do is I will break this into two fractions. So I will have s plus 15 divided by s squared plus 4s subtract 32 will be equal to, because I have two factors, so I break that into two fractions. So s plus 8 and s minus 4. Okay, so let's go back and review what we have up here. So when we work with partial fraction method, we have to break our fraction into the fraction decomposition. So I should have two fraction decomposition in this case. And I do have non-repeated linear factors. Linear means I have s to the exponent 1, s to the exponent 1, and they are non-repeated. So my fraction should be in this form. So on here I should have A, and here I should have B. So I can write my statement as s plus 15 equal to A times s minus 4 plus B times s plus 8. Okay, so we pay attention to this statement. And to get from this fraction to this equation is actually a very tedious process, but I believe that everyone already know what to do with this in previous math courses, so I will skip all of that stuff. Okay, so at this point I would like you to take a look at A multiplied by s minus 4 plus B multiplied by s plus 8. In order for us to solve for A and B, we are going to use the concept of arbitrary root. I'm going to choose this s equal to 4. So why do I do that? If I choose s equal to 4, I can eliminate this term. So this could become 0. Then I can solve for B. Okay, so let's write it down. So s plus 15 equal to 0 plus B multiplied by s plus 8. Okay, this method enabled me to solve for B, because in this equation I have unknown A and unknown B. Two unknowns in one equation. If I want to solve for two unknowns, I should have two equations to work with. But in this case, I only have one. So using this method, I can eliminate one unknown and I can solve for the other. So in this case, I will put in s equal to 4. So 4 plus 15, and here's 4 plus 8. Now I can solve for b. So 4 plus 15 equal to 19. 4 plus 8 equal to 12. Okay. Divided 12 over to the other side. I should have b equal to 19 divided by 12. So let's circle that. The next step is, let's rewrite our statement. S plus 15 equal to a times s minus 4 plus b multiplied by s plus 8. So this time I want to solve for a. So I'm going to let s equal to negative 8 so that I can eliminate this term. So this one becomes 0. So I substitute s equal to 8 in here. So 8 plus 15. Negative 8 plus 15 equal to a times negative 8 subtract 4. So I should have positive 7 equal to negative 12, 8. Divide negative 12 over to the other side. I should have a equal to 7 divided by negative 12. So let's circle that. So now at this point, I can write fs equal to negative 7 divided by 12, all of it divided by s plus 8, plus b, which is 19 over 12, all of it divided by s minus 4. Okay, so let's take a look at what transform that we have to use for this statement. So let's go to our Laplace transform table. I can see that I need to use transform number 3 because as the denominators you have s plus a, and here you need 1. Okay, so let's get back to our solution. So I'm going to use transform number 3. Okay, using transform number 3, I should have a equal to 8 here, and a equals to minus 4. Okay, before I do that, I should factor out negative 7 over 12. So on here I should have 1, s plus 8. Here I should have 19 divided by 12, and I have 1 over s minus 4. Okay, now I'm ready to take Laplace inverse of this fs. So Laplace inverse of this fs will be equal to minus 7 over 12 multiplied by e to the exponent negative at at 19 over 12 multiplied by e to the exponent negative of negative 4. So I should have positive 4t. Okay. So if you want to simplify this further, what you can do is you want to factor out 1 over 12. So inside the bracket you should have negative 7e to the negative at plus 19 times e to the exponent 4t. If you want to factor further, it's fine. But however, I think it's best just to leave it like that for now. Okay, so what I would like you to draw from this lesson is this. You are working with function with quadratic denominators. So question number 2, you have the quadratic denominator as s squared plus 6s plus 26. Question number 3, you have s squared plus 4s subtract 32. So In these two quadratics, what you have here is you are using completing the square. So in this one, we are using partial fraction method. So how do we know that? Okay. To know that, we should use b squared minus 4ac. So in this case, it's less than 0. We also test that b squared minus 4ac is actually greater than 0. So we are using partial fraction method in this case. And then we are using completing the square for this function. Alright, thank you.